Hi, I'm Thomas. Welcome back. Our topic is integration. This is integration using substitution, example 3. Our requirement reads, use the substitution u equals x plus 1 to find the definite integral from 0 to 2 of x times quantity x plus 1 to the power of 3 with respect to x. Going to our algorithm, step 1, identify function type. In this case, we want to identify that we're working with a substitution. Step 2, apply integration rules. Let's start with the given substitution, u equals x plus 1. We're going to, looking at the original integral, here we find 3 x terms. All 3 of those terms we want to use an appropriate substitution so that we're dealing with u and with respect to u. U equals x plus 1 is the given substitution. The derivative of u with respect to x is 1. If we then multiply by dx, we have du equals 1 times dx, or simply dx. Looking at the original integral, we have a replacement for x plus 1, that will be u. We have a replacement for dx, that will be du. We need a third substitution, which is for x. If u equals x plus 1, that's the given substitution, we can subtract 1 from both sides. U minus 1 equals x. This is based on our given substitution, and now we have substitutions for all 3 components of our integral. I'm going to write the integral in terms of u, for now leaving out the limits of integration. We'll look at those limits in a moment. X is replaced with u minus 1. X plus 1 is replaced with u. That term is cubed. With respect to x is replaced with respect to u. And now looking at the limits of integration, we've changed from x to u as our variable. Given the substitution, the relationship between x and u equals x plus 1, let's input into the x column our original limits, 2 and 0. In terms of u equals x plus 1. So starting with an x value of 2, 2 plus 1 gives us a u value of 3. And the x value of 0, 0 plus 1 gives us a u value of 1. So the limits of integration are now from 1 to 3. Because we've changed the variable of the integral, we also need to change the limits of integration to match the substitution we're using. Now I'll rewrite the integral, distributing the u to the power of 3. We have the integral from 1 to 3 of u times u to the power of 3 is u to the power of 4, minus 1 times u to the power of 3 is u to the power of 3 with respect to u. Now we can integrate. U to the power of 4 becomes u to the power of 5 multiplied by 1 over the new exponent, 1 over 5, minus u to the power of 3 becomes u to the power of 4 multiplied by 1 over the new exponent of 4, with our limits of integration of 1 to 3. Because this is a definite integral, we will not include a constant of integration. Let's go to step 4, simplify. We'll start with an input of 3. 1 over 5 times 3 to the power of 5 minus 1 over 4 times 3 to the power of 4 minus 1 over 5 times 1 to the power of 5 minus 1 over 4 times 1 to the power of 4. The first set of brackets I'm using is optional, but the second set is critical because I need to be sure to distribute the negative in front of that second set of brackets. Continuing to simplify, we have 1/5 times 3 to the power of 5. 3 to the power of 5 is 243. That will be over 5. Minus 1/4 times 3 to the power of 4. 81 over 4. Minus 1/5 times 1 to the power of 5 is 1/5. Minus 1/4 times 1 to the power of 4 is 1/4. Now I will rewrite distributing the minus sign 243 over 5 minus 81 over 4 minus 1 over 5 plus, this shows the importance of the brackets, 1 over 4. I have minus 1 over 4. Distributing the negative sign results in plus 1 over 4. And completing the arithmetic, we end up with 142 over 5. Using the given substitution, we found the value of the given definite integral as 142 over 5. Notice that we did not revert back to x. We didn't re-substitute like we do with indefinite integrals when we use substitution. The reason we didn't need to do that was because as part of step 2, we changed our limits of integration from x-based limits to u-based limits. And once we made the change in the limits of integration to be based on u, we no longer had the need to revert back or re-substitute back to the variable x. We've completed our requirements. This concludes integration using substitution, example 3.